record it. Doot, 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 doot. Okay. My name's Ethan. I'm also known as Nathe. I'm giving the talk about cable. We're going to basically cover how to insert your own channel onto an existing lineup. That part's going to take about 5 minutes if I blow through it. Probably a little bit longer because I ramble. After that, Q&A, and we'll cover anything from the basics of how the HFC distribution system works to stuff about cable modems or anything like that if you want. Don't start. Don't trust this AV system right now. Okay. If you can get the push the red. I am pushing the red button. Oh, okay. That's nice. All right. What we're going to start out with first, it's going to be relatively simple. It's going to sound stupid to people, but basically the most important thing about your cable system is actually the physical equipment you use. Cat5 makes a difference. Let's see if I can get out here without getting feedback. This is one of the worst wires that you can run. If you want to pass it around, it's called RG59. If you look at it, you'll notice that there's absolutely no shield, that the actual conductor itself is very small, and that it's very easily bent and all that kind of stuff. You'll find a lot of old houses because it was cheap. A modern system will not run on this. It will trash your digital cable, trash your modem, and you can buy it at Radio Shack. The other thing is splitters. Yes. Our old friend, the gold splitter. Now, this splitter, I don't think I can bust it open easily because I'm trying to hold this. By the way, I apologize for being a little bit unprepared. I've been trying to run the gaming, and it's not working very well. If I can bust this open, you'll notice that there's actually no electrical components in here except for a little bit of wire and a little bit of solder. That sets up all kinds of weird harmonics, all kinds of weird reflections where the signal is actually being transmitted back and forth inside the splitter to the various lines that are going there. You won't notice it too much on an analog signal, but it'll really screw with QAM. All right. Cable itself is set up in 6 megahertz blocks. It's just a frequency division multiplexing system. Every 6 megahertz is a new channel. So to insert one, what you have to do is either find an empty spot or you have to create an empty spot. There's pluses and minuses to both. By the way, I'm starting to pass around the thing that you don't want to use. So to create an empty spot is the best way to do it. It's also the most expensive to do correctly. You have to find a channel that you don't want. I actually recommend something like channel 3 or channel 4, whichever is the blank channel in your local coverage, because the cable systems tend not to keep that actually, or not to move it around, not to insert different things onto it. And it tends to be like a local access government channel, which, while it's nice, it's not terribly interesting. So what you have to do is you have to take the existing channel 3 or channel whatever off. You can get filters at either online for any actual cable or AV store that actually specializes in this, or you might be able to get it at some of the local shops. I don't know. You need what's called a notch filter. You need to take off a notch filter only takes out a specified frequency range. Most of it actually, most filters you get or most filters you see are for the cable company, and they'll actually knock off a wider range of channels. Which in this case, if you really want the channels around your signal to be trashed, you can do that anyway just by leaving the filter off and turning the modulator way the heck up. It's not a good idea. So you take the signal off with the notch filter, and then then that line goes to the splitter backwards. The other one, you have whatever your signal source is, be it a DVD player, be it an Xbox that you've hooked up in a closet and you have a wireless controller, be it a Myth TV box like the one you'll see in a couple hours. Whatever it is, you output it to a modulator. That modulator then puts the signal on the correct frequency, and it then goes to the splitter. A decent splitter, unlike the gold one I'm passing around or all the other examples of crud that I've got, actually has isolation in between the outputs so that you don't feed something in and have it coming back out. That's good for a couple reasons, because you don't want... cable is basically a big antenna. Literally, it's a big contained antenna. That's all it is. RF, same as you get off air, same as anything else, Wi-Fi, whatever, flows over the line because it's the easiest propagation method. That signal can come off if there's a break. If you have, like on the splitter that's passing around, if you notice how the braid is sticking out and all over the place, it's not making a very good connection with the fitting. The signal will escape through that, or will enter through that, which is called ingress. That's why you get ghosting on channel 2 or whatever local TV station has an antenna set up 5 miles from your house, broadcasting at 5 times the power of the cable actually hitting your TV. It enters, and you get just a timing difference because it's just triangulation. There's 2 legs to go over for the cable, and there's 1 leg to go for the TV. So you don't want anything like that flowing backwards across the network, because not only will it mess up your TV, but it'll feed back, and you can actually trash any number of services along your entire node. In fact, if you do it bad enough, they'll cut you off until it's fixed. So a good splitter has isolation in between the outputs. However, you need a path back to the input so that your services like cable modem, video on demand, all those things will work, because they actually transmit back along the cable line below channel 2. So, what's called the reverse path. But when you have, sorry, I tend to ramble. When you have your modulator sending your signal out, you have your notched signal coming in from the cable. It's joined just a 2-way splitter, or if you have multiple insertions, you can use a 3-way or anything else like that. And it goes out, and then it's distributed across your house. The problem is that it's very likely that the modulator is not putting out anywhere close to the same amount of signal that's coming in on your house. So you actually have to adjust the signal level either on the modulator or on the house feed. If you don't have a signal meter, it gets more interesting, but you can still do it. The reason is cable channels that are adjacent to each other, if they do not have a basically even level signal-wise, you will get harmonic distortions on the adjacent channels. They can show up in different ways, but usually they show up as black bars, or weird sort of a moire pattern in whatever's on the actual feed on that other channel. So if you look at your modulated channel, and unfortunately, like the one in the hotel, if you look at it, you can still see a little bit of channel 17 coming through. If you notice that kind of distortion, you have to amplify or equalize that signal. That one's lower than the rest. So you can either do that by sticking an amplifier on the actual line itself, and then feeding your network, or you can knock down the input signal by using a splitter or a pad. Every splitter actually loses about 3.5 dB. And depending on the frequency range, there's about 0.3, 0.4 dB of wiggle between the low end and your high end. You'll lose more on your high end, just as you lose more on your high end going across cable. We'll cover that later if we actually get to like system design and that kind of stuff. So what you have to do is if you notice a problem on your modulated channel, I would actually recommend, unless you have a lot of TVs and you have a lot of like dig boxes or things like that, that you knock down your input signal. You can do that again with a splitter. Just run a splitter and terminate it so that you don't have an empty port. That's another spot for ingress, that kind of stuff. You probably won't notice it, but it's just good practice to do so. So run it through a two-way, three-way to lose signal. While we're on that then you check it out again, see if you've noticed that distortion still. If you notice it on the adjacent channels to your modulated channel, all you have to do is knock down the modulated channel. If you get a good modulator, you can actually do that just by turning a screw in the modulator, which is really handy because you don't need to go through weird splitter configurations and all kinds of junk like that. They range. The one in the hotel will probably run you about $200 for the modulator. A great notch filter like the ones they use in the hotel will probably run you about $150, $200. You can get them a lot cheaper than that, and they'll do the job. You got to understand that the modulator that they're putting out here puts out about 50 dB. The signal that's actually hitting your back of your TV is at 0 dB. That's good. That's a good segue. Cable signal is actually measured in decibel millivolts. Decibel millivolts, just like all dB, is logarithmic scale. Every dB you go up actually adds about 3 times the signal, which is why you don't want too much signal hitting the back of your TV. There's actual voltage on that line when you get it up high enough. You can fry your tuner. If you plus the fact you can overdrive it and you start seeing noise, which is actually what's happening on this hotel. If you notice the channels are really sort of fuzzy, not all that is just bad wiring. A lot of it is the fact that the signal is too hot, and you get what's called string noise because it's distortions that look like this across the thing, across the line. If your signal is too hot, you will do that. You will also knock your cable modem offline. You will render your digital channels unwatchable, and a number of other things. That's one reason why you want to knock everything down to an even level before amplifying it. Is that also you don't want uneven amplification because again you will get harmonic distortions on adjacent channels. Now the more interesting one is if you do have a lot of services that need to talk back. Because every time you split, again, you lose 3.5 dB. That's not, you don't lose 3.5 dB through an 8-way, you actually lose an 11, because the 8-way is just a 2-way on top of a 2-way, and then it's split out. It's sort of in a pyramid pattern. So if you have a lot of TVs, you're going to lose a lot through your reverse path. And that amplifier, in fact, most amplifiers don't do anything for the reverse path because you don't want noise inserted on it. You don't want noise being fed back to the cable line because, again, you'll knock out the rest of the people on your node. So what you have to do is it's sort of a balance between services that you need on the forwards channel and services you need on the reverse channel. So if you have a lot of services that require a reverse path, that are not just straight up TVs hooked to cable and standard tuning, what you can do is you can run simply the you can amplify your modulated signal if it's weak at the place where right after the modulator, and that will bring your signal up, and you can adjust it at that point so that it's even with the rest of the signal coming in, and then you can distribute it, and your reverse path is fine. It's not touched any other than the normal wiring. You actually lose a little bit more reverse through even a good amplifier. So once that's done, all your TVs should work just fine. You should see a good picture. The problem is cable modems don't like to be amplified. They like their reverse. I mean, because it's not much good if you have downstream if you don't have any upstream. So normally cable modems are split off before the amplifier. They don't even get passed through an amplifier because again, you can get distortions, and you don't want it too hot hitting a cable modem. You'll start losing packets. So what you have to do is you split it off. It is split off before the amplifier, before anything is done inserting a channel. You split that off, send it to the cable modem. It's happy in its own little world. It doesn't have to worry about your modulator. It doesn't have to worry about any splitter. It doesn't have to worry about any harmonic distortion. Nothing. So you split that off first, and then you run and do the same kind of configuration. You notch your channel off, go through the splitter, have your modulator sent up, and have it balanced. By a modulator? You don't need to. No. The reason that cable modems are a little bit more twitchy is that they don't. Okay. The DOCSIS specification says that the forwards channel, which is on the high end, needs to be between 0 and -10 decibels. In practice, that really runs between like +5 to +8 and about -15. Most modern cable modems can handle that range. You don't really want it to get below that because cable signal varies during the day due to heat and all that, any number of other factors. So it requires a certain amount of signal on the high end, and then it requires a reverse path between 38 and 56 dB. Now, the reverse path is sort of weird. The lower the number, the stronger your signal, because it's simply a measure of how many decibels are necessary to reach back to the first amplifier, at which point the amplification system that Comcast has takes care of it. Once it reaches there, it's cool. So 38 simply means that it has to send out 38 dB of reverse signal to reach the amplifier. 56, again, 56 dB of signal to reach that thing. Big boxes, on the other hand, I've seen them work on reverse of about 65. So you have a lot more leeway, and you don't have to balance it quite so much. As far as the forward signal, if you're talking about like picture quality, if you've got MPEG tiling, that type of stuff, because that's all digital cable is. It's an MPEG being streamed to you. In fact, VOD is being sent over UDP. It's just completely, I don't know why that keeps popping. It is sent completely over UDP. Your box has an IP address. In fact, I think it's in Nashville, it's a 93 dot range for some reason. And there's a nice server set up on the head end side that just streams it from hard drive array. But on the high end, the digital cable isn't quite so touchy as the modem signal, partially because it's not quite so high up there. Also, it can be a little bit stronger without distorting on the cable box side, simply because they're designed a little bit more ruggedly than the modems are. So the harmonic distortion that I was talking about with the adjacent channels really falls off, because what you it's just like how to explain that? I'm sorry. Your strongest harmonic distortion are going to be on the channels exactly next to it, and then three channels down, and then another 3 channels down, but it'll fall off in level. So by the time it reaches the spectrum, unless you're inserting it up in like the channel 78 range, it won't make a difference. What I'm going to pass around now is actually a sort of out of date, but example of what a channel lineup actually looks like to the cable company. And what you're going to see is the first page is from the T band, which is actually below channel 2, which is at 55 megahertz. The T band ranges from 5 megahertz up to about 50. Then there's a gap to allow the harmonic stuff and to allow splitting of the signal. in the system. Well, I guess we'll touch on that if we get to the cable distribution system. But the interesting thing is, if you look at the bottom and at the actual the second page, you'll notice that the digital channels are not one digital channel per 6 megahertz band. The normal standard 480i channels can be stuffed 6 channels to one analog channel. There's a device in the head end called a cherry picker that does that. So, yeah, and actually it's sort of cool. I mean, I guess we can touch on that for a second. It takes the satellite feed and decodes it. I don't remember what format it is, but it's a digital format. It decodes it, and then looks according to whatever preferences are set. It actually assigns a certain amount of bandwidth, a certain amount of bytes to each channel. And so you can have like a channel that you don't quite care about so much because it's not one of your big name channels. You can have it occupying about this much space, and you'll notice more compression, distortion, and all that kind of stuff. They try to balance it out so you don't get to that point. But you can have one that's taking up about this much space on your line, and then you can have like an HBO or a big name like ESPN or whatever. You can have a larger chunk being assigned to that, so it'll be clearer. You have less compression. But it formulates that all into it and sends it down the line. Your cable box looks at it, goes, okay, I want this part of that channel, and displays it to you. It's both. As weird as it sounds, you got to remember, cable itself is a frequency division multiplexing system. The stuff that's coming at you in that 6 megahertz band is not really time multiplex. It's all sent in one packet, or one chunk of information, one clock cycle. All of that information is sent each time. You have to understand. Let's touch on the digital channels for a second. Digital channels are sent in QAM. QAM is quadrature amplitude modulation. It's got two different types of modulation going on at the same time. The first is quadrature. There are two different 90-degree carriers that are going on that indicate they're 90 degrees opposite of each other on the waveform. What happens is the cable box or whatever's reading it follows the phase shifts. So it's not just a standard analog, you go up and down kind of thing. But it actually follows the phase shifts where, okay, this is a 90-degree shift, this is a 180-degree shift, whatever. And that generates, because you have two of them, and you have that means you have two shifts that you can follow. That means you have 2 bytes sent on each clock cycle from that. After that, you have however much amplitude modulation you want to put into it. The more modulation you put in, the higher the number. Means the more bytes you can send per clock cycle. However, it also means that the more vulnerable your signal is, because the less space in between each divider is. So any noise will make that number jump, and you'll break up, and you'll get tiling because it trashes the actual information sent to you. But right now, Comcast is in the process in Nashville of shifting everything to 256 QAM. That means you can send 256 bits of information per clock cycle. I don't remember the exact clock cycle. I think it's a 60 hertz clock, but could be wrong. That's the weirdest pop. If I remember correctly, that modulation gives you something like 40 megs per second on that channel. Yeah, the cable can go really fast. On the door to Tech Ops right now in my division, there is a list of cable modems called end-of-life modems. One of those end-of-life modems, mind you, this is a modem that we're phasing out, is being phased out because it does not do 16 megs per second down. Now, you're not going to be getting 16 megs per second down simply because there's too many people in the node, that type of stuff. But that gives you an idea of what an actual cable system is possible. Not to mention the fact that you can have multiple downstreams, because again, you've got multiple channels. DOCSIS specifies you can have you could have an entire channel lineup full of DOCSIS. In fact, that's probably what's going to happen in the long run, because we're going to go to stuff like complete on demand, and everything's going to be streamed over UDP and all that kind of stuff. Not to mention the fact that the demand for internet products is just escalating immensely, as I'm sure everybody here knows. So, you know, the speed is only going to increase. Cable can compete to a certain extent with fiber to the curb, to a certain extent. The problem is that we also have to. The cable has legacy issues of the analog channels, because analog channel is one channel per 6 megahertz band. That's why Dish can offer so many more channels than we do, because their people have to buy receivers. They have to invest in the technology that lets them get all of these channels. And that means that the Dish itself can actually just say, okay, we offer no analog channels, which actually becomes a selling point to them. You know, all digital, all da-da-da-da. But if the cable company tried that, you would have a revolt. Every single person would start screaming to their senator. Every single person would come down and storm the cable office, and you'd have no cable service because it would be burnt to the ground. All right, but because we have to deal with the analog channel, that takes up over half of our channel range, and that's over half of the bandwidth that we can assign. So before we get into that, does anybody have any questions? Is anything okay? What regarding the actual channel modulation? Okay. Yep. Yeah. There's a couple things going on. First of all, you can get your own QAM tuner. First of all, the card. What you want to look at is the QAM rate. Again, Comcast is shifting to straight 256. Right now, there's some 64 still left, but what they're doing is they're starting on the channels that are least likely to get distorted or to have system issues or anything like that. They're starting with those. They move that to 256. They fix the issues that are caused by those. They wait a while for that to sort of settle out. They shift the next block to 256. And so, you know, it's a little bit more delayed rollout, and you don't have everybody going, oh my God, my digital cable doesn't work. So you need to look at the QAM rating it's capable of. The other issue is that a lot of the digital cable channels right now are encrypted. So that's why, for example, Dolomite, who's going to be giving the Myth TV presentation, he has a QAM-capable tuner. It's an external, cable tuner that it can pull it off of. It can pull HD off of air for that format, or it can pull QAM off of the cable line. He doesn't get all of the cable channels just because he has a tuner that can read it, because they're encrypted. So most of the TV cards that are out right now don't support encryption, because it's really hard to tell a piece of hardware, okay, this is how you do this, but just don't do it. I'm sure everyone in here. Well, no, I'm not saying this is not legality. No, they don't know how to do it, so they don't enable it. Yeah, we've got clearly broad-crusted. Yeah, that's real good. It's a pizza. The problem is getting the hardware to understand it. The problem is getting the hardware to understand it. If you can get it to pass you the information, regardless of whether it understands it, you might be able to get it. But most of it, I don't know. I haven't had the chance to mess with it. If you can make your card pull the raw data out, yeah, you probably can. The other thing you could do. The other thing you can do is you can try to trick your cable box, but I'm not even going to go in there because this is being recorded. Yeah, I like my job for right now. It, okay. Again, I'm not covering that because I like my job. um, yeah. Partially because the encryption hardware, the encryption technology, like the hardware to actually do it, is sort of expensive. Because again, you've got to deal with the cherry pickers and all that kind of stuff. It's actually in total blocks. If you looked at the channel lineup, those blocks are encrypted one at a time. So first of all, they do the ones that are most sensitive, like HBO, all those things that people would love to get for free. Then they do stuff where what's that? Yeah, it's Spice, Playboy, all your softcore porn, Skinamax, whatever you want to call it. Um, all that stuff is encrypted because they don't want people to get that for free. Yeah, it makes them a fair amount of revenue. Then they move to contractual obligations like ESPN. If you want to complain about your cable rate, yes, the cable companies make money. Yes, they do. Comcast is actually the only cable company that is not operating at a daily loss. It's actually sort of funny. Most cable companies operate in the red. The reason Comcast is in the red is because we bought AT&T. We bought the third largest, bought the biggest cable company out there, and assumed all of its debt. But the other thing is that channels like ESPN, the must-have channels, have a big pull over the cable companies. They get to negotiate their rates because what happens if Comcast drops ESPN? How many people are going to drop Comcast? I mean, seriously, like in Nashville, who's going to go without being able to watch the Titans? Well, me, but that's not the point. I don't watch. It's ironic. I don't even watch TV. I get it for free. It's weird. Okay, you had a question? Okay, yeah. Let's talk about that. Oh, that's spam. Look, we've got a digital cable filter. Really? I'd like to see that. You got to remember, this is something that requires a tuner to actually decode. There's no such thing as a digital cable filter. You can knock it off there, but you can't do it. You're talking about the frequency blocks. That's your reverse path. Okay, if you don't want to be able to order a pay-per-view, cool. You can block that off all you want. But the way that the pay-per-view system works is you go, I want this, and it gives it to you. If you're talking about the scrambled analog channels, what you need there's two ways that can be handled. The most used is an active scrambling. You have to have the matching key that's in your cable box. Again, you have to have authorization to do it, or you have to trick it into it. But again, not covering it. The other way is that they can actually just take out the carrier and just have the raw modulation on there, and then the cable box itself inserts it gathers the carrier from the channels around it, and then takes that carrier for that channel, and at which point you have the data back. That's what Comcast uses, or in this area, which is why if you try to tune to one of those channels, you get it all scrambled because it just doesn't have you can see parts of it, you can see that there's data there, but you don't see. You can't watch it because the TV just cannot lock onto it. You can get around that. You can, if you want to insert your own modulation on it, cool. But at that point, why don't you just order the pay-per-view? That's what they work on. All these things can be broken. Okay. All these things can be broken. There are ways. There are simple lock. It's like WEP. If you're war driving, yes, you can break WEP really easily. But look, you've got another one that's open over there. It's to keep the majority of people off, because the majority of people aren't really worried about spending the money on breaking it. But the other thing that you can do is you can trap off channels like HBO and Showtime, Williamson County, and all of the surrounding counties. It's not scrambled. It's broadcast in the clear. All you have to do is remove that filter. Which again, it's just a notch filter. Same thing that they're using, that I was talking about using to strip out channel 3 or whatever channel that you want to insert it on. Actually, it'd be funny. If you wanted to, you could take the filters off your pole and put them on your line that you wanted to notch, and after you split off for whatever TV you wanted to, whatever TV you wanted to have HBO, and you could use HBO on the rest of your TVs as, as the channel where you had your Xbox or whatever. But that's basically the two basic methods of deauthorizing content. It's funny, cable is not a default deny system at all. Yeah, you can very easy. Tune to that channel. Do you see scramble or do you see snow? That's basically it. Speaking of snow and speaking of looking at channels, there are a couple blank channels sometimes in cable lineups. When you get up into the 70s and 80s, it looks like a lot of snow, doesn't it? Most of the time, or when it's not scrambled. Well, the problem is that most of those are actually the digital channels. So if you stick your channel on top of that, even if you think it's empty, first you're going to lose your digital channel. You'll probably have the channel you modulated on top because analog requires requires a much stronger signal. Digital actually is 10 dB below most analog carriers. So you're going to have your channel you modulated, but you can lose HBO or Speed Network or whatever else you modulated on top of. So that's why you really sort of want to go to notching a channel. And I recommend, again, 3 or something, because cable companies move their lineups all the time to whatever is the most advantageous to them. So if you spent all this money getting notch filter and all this kind of stuff, the next day they change their lineup on you. Yeah. Okay. Any other questions about the modulation stuff itself? Like. Oh, I don't know, quite honestly. I sort of doubt it because that would be a really high-end filter, and most of those are actually almost the size of the projector. And they have multiple filters involved, and they each take off a little section of the signal. So to be able to do that and to be able to change it, I sort of doubt. It's possible. I haven't looked. I recommend you go look at AV shops or on stuff online. As always, Google is your friend. Let's see. Anything else about modulation? Cool. Quick poll. Do you want to cover system distribution issues or do you want to cover HSI stuff? Doesn't matter? Okay. Let's talk about the distribution system. HFC, hybrid fiber coax. I'm sure you've all heard, and I know I've mentioned it, a node. All a node is a place where it bridges from fiber to coax. It'll also, depending on the way the head end and the subhead are set up, will allow you to do things like narrow casting to a single node and that kind of stuff. But a node is simply where it bridges from fiber to coax. And back the opposite way for the reverse path. We need to talk about that now in a little bit greater detail because the way the system actually handles the reverse is sort of interesting. You have that split at 50 megahertz and regain at 55, where actually I believe the telemetry for the reverse tester is sitting at the RSVP. The system actually splits that out. When it comes into a line amplifier on the forwards path, it has what's called a diplex filter, which actually has 2, but don't worry about that. It splits the frequency into 2 different ranges. The same thing that happens with like the cable satellite diplex filters. You have one coming in one, and then they both go out the other. Well, it comes in, it splits off the forward path, does its work on that, and then on the other side, the reverse path joins back in. Because every splitter, every filter, all that type of stuff is two-way. So it takes its reverse path, it takes its forward path, does its work, and then there's a second diplex filter on the other side that rejoins the signal there as well. The reason that you need amplifiers on a cable line is pretty simple, actually. It'd be nice if you could send the signal out burning, just incredibly hot, coming out of the head end, and just keep knocking it down, because you can have what's called a directional coupler. It's an uneven split. They make them for the houses. They can be sort of useful, but it'd be great if you could do that and just have taps of insanely high values, like a 300 value tap, where you get the same amount of signal coming out of the end of it. The only problem is that cable signal loses power unevenly. When a car drives down the road with its bass kicking and all that kind of stuff, you hear the trunk rattling, but you hear the bass only, usually most of the time. You don't hear any treble, you don't hear any snares, anything like that. The reason is that low frequency travels and propagates much more easily than high frequency. The same on cable. The signal actually comes out of the head end or out of any amplifier, any node, comes out tilted. The high end is much higher by, I think it's like 17 dB, 16 dB of tilt, depending on your system. Because not only does it lose signal going across the system, but it loses even more going across the line coming to your house. One of the reasons that cable, the 59 that I passed around earlier, is so bad is that its attenuation factor, the loss in between the high end and the low end, is so much higher that by the time if you had 59 from tap to TV, you'd lose so much of your high end that it's worthless. Your digital channels would be gone, your modem would be gone, all that kind of stuff. The reverse is true for the lines out on the pole. They have lower resistance, so the actual attenuation difference is not that great. Plus, they have just straight up lower attenuation. They lose less dB per foot on everything. So it comes out tilted, and as it travels along the cable, line, the high end falls and the low end falls, but they sort of equalize until they come to an even point. At which point they don't amplify it; they actually extend it even more until it falls, and the high end is even lower than the low end. That's called negative tilt. At that point, I don't know the exact specified tilt value. That's something engineering does. I don't work with it. They have an amplifier. So what they do is when it enters the amplifier, the first thing they do is they bring that low end down till the point it's even with the high end. They have a preamp that moves it up a certain amount, and then the post amp tilts it, it amplifies the high end, and sends it back out. So that, again, you have your tilt, and you can lose off the high end. So it's just a constant tweaking along the entire system. This is one of the reasons that fiber is so great. This is why fiber is awesome. You can send so much stuff around it. You can use high frequencies, all that kind of stuff, because it has virtually no attenuation compared to coax. It's expensive. It's expensive. You know all those companies that were running fiber all over the place, and yes, we're going to have it all over. Yeah, Verizon, Quest, and any number of the other ones that you can actually still see the fiber all over the place. It's expensive. They're out of business for a reason, or they're not in that business for a reason. Now, we are starting to see the fiber to the home for very specific uses. That's because the fiber has sort of crept out, and the telco wars between Comcast and all the bells and all the other things have escalated to such a point that it's necessary. They just cannot compete with America's degrading infrastructure. We're running on copper that's 30, 40, 50 years old. That system is not going to work for a high data rate. Remember these chains of amplifiers. Every time it goes through a signal goes through an amplifier, it actually inserts noise. The strength of the signal is not important. It's like when I'm talking to you. I could be yelling at you at the top of my lungs, but if I'm yelling at an airport, it doesn't do me a damn bit of good. If you got a plane flying overhead, if you got a lot of noise, you can't understand. Same thing with cable signal. The relative strength is more important. The signal to noise ratio is more important than the actual signal level. The reason that low signal is a problem is because that as it goes along, as it attenuates, the signal level drops. The noise floor doesn't. The noise floor is a random electronic movement and random electron movement and random electromagnetic noise generated in the amplifiers, all kinds of other things. That does not go away because it's part of the actual signal. It's added together. It's not two separate things. It's added together, and every time you go through an amplifier, it inserts more noise and it changes the signal even more. This is why cable used to look like total crap. Because right now, with the HFC system, we usually don't go more than 6 amps deep, be they bridge amplifiers with multiple outputs, or whether they're line extenders with a single in, single out. We don't go more than 6 deep, unless there's a problem and we're just sort of stringing along until we can do a rebuild. In the old days, they used to have chains of amplifiers about 70 long. So by the time you were at that last one before it hit, yeah, your cable looked pretty much like snow. You also, of course, had amplifier cascades that you'd have an outage at the top of the chain, and everybody would be out all the way down the chain. That's QAM. That's what QAM does. It's phase shift keying. You've got the two 90-degree separated waves. So yes, you can do that with analog signal. It's not done because we don't understand the tuner. The tuners don't understand it. But you can theoretically do it. But there's no point at this point because we're moving to something like that purely for the signal distribution itself, not for signal integrity. Quite honestly, I'd be more interested if you're looking at ways to do long distance signal transmission, that type of stuff. I'd be more interested in retransmission than digital retransmission than modulation tricks, because right now the modulation is pretty set in stone. It's really hard to change standard once it's out there, once it's built into hardware, and once people have spent money on it. You have a question? Okay, you're scratching. Okay, but yeah, better than modulation tricks, although they're nice and they do awesome things. I mean, QAM is great. I mean, it's awesome. If you're looking at the channel lineup, the last one of those is the music channels. We have something along the lines of 47 music channels. All of those music channels are in one 6 megahertz band. Every single one of them. Yeah, that's why it updates like every 6 seconds, because they send an MPEG refresh. They send the video frame every once in a while, and it just holds it until the next frame. So all those audio takes basically no space. I mean, that's why MP3s are so much smaller than MPEGs, all that kind of stuff. But what would be more interesting to me is to have the bridge amplifiers, because they're more expensive anyway, have bridge amplifiers be digital retransmitters. Now, it'd be much more expensive because you'd need something that understands the actual QAM and decodes it and then just rebroadcast it. It probably wouldn't be that hard. I'm not an electronics engineer. I'll leave that to Bob Burner or somebody else. Okay, cool. But let's see. We're talking. Fiber. Okay. The reason fiber is awesome is because you can use frequency ranges that you can't even touch. in coax because the attenuation is simply so high that you'd have to have an amplifier every 100 feet. The resistance of fiber line to optical signal is so low compared to the resistance of copper to electron movement that it's just no comparison at all. So you can use these really freaking high signals. You can stuff these things really up high in the range, and they'll fall. I mean, everything falls, everything attenuates, but it takes 100 miles to what would take a mile of cable. Well, I don't know. It depends on your frequency. I mean, really, there's a couple different frequencies that are commonly used for fiber, but they don't let me play with that. If you can convince them to let me play with that, please see me. Hi, I'm here. Yeah, I mean, so that's why fiber is so much better. But again, part of the reason optical stuff is so expensive at this point is because you have to take it back to electronic and then shift it back out to optical again. So that involves a lot of equipment. Once we actually get like optical processors and all that kind of stuff, it's fiber is going to become more affordable to a certain extent. A fusion splice runs you about $3,500. The equipment to put together coax, even system distribution coax, it'll cost you about $200. So, not to mention the fact that the line's more expensive, all that kind of stuff, because it's harder to make. Any questions about distribution or anything? They do nothing. Not only can, well, there's two things. First of all, you're going to see everything coming at you. There's incoming packets are incoming packets because it's sent all the way down the line. It's a shared medium. It's just all the way down. And you'll see everything on the forward side. What you'll see on the reverse side is what comes past you. So if you're closer to the node, you'll see most of what's on that leg of your node. I don't know. Individual cable modems may implement some filtering, but in general, it's not done. The other thing is, and this is really the part of the important thing, that the cable modem is just a bridge. That's all it is. It does not put its own MAC address on anything other than control transmissions. It has its own internal IP address. It used to be a 10 dot on our network. Now they're shifting to a 73 dot, but let's not go there. It's controlled all over a separate logical network. Everything you send out, everything that leaves, is on the MAC address that it hits the cable modem. So you can literally sniff everything.
So when are they going to stop spamming hard?
Yeah, ask Philly that. Yeah, well, some of that's really it's really hard. We got a lot of people. I mean, we got a lot of people, and the CTMS, cable modem termination systems, the routers and the head end, they know where stuff is to a certain extent. But you got to remember, when you're even narrowcasting to an entire node, each node has 5 outputs. Each bridger amplifier has either 4 or 5 outputs. When you think about the fact that you can pass probably 300 homes on a straight line if you follow that, and then you branch out after that, there's a lot of people on those. Yes, it's annoying when they're spamming ARP. There's any number of problems going on with it. They're working on it. There's a lot of things that concern me. ARP spamming is the least of them. More concerning to me was the fact that they had to learn from failure that you don't want 1 or 2 DNS servers halfway across the country. In the same building, on completely both on the same side, of the both of the same side of the peering point. Okay. Yeah. Well, I mean, I'll keep talking if people keep asking questions, but if people want to stretch and go, I'm cool. I don't know. Is Scott? All right. Well, I mean, that's cool. Any last minute short answer questions? Google is your friend. Okay. Yeah. IRC is your friend. I try not to touch too much on the dark side of cable, even online, simply because yeah, that gets you fired. So yeah, I mean, if you have any other questions you want me to talk to my I'm reaching the extent of my knowledge about distribution system, but I mean we can always I can always speculate to you about certain things. If you want, if you're interested, find me. I'm probably going to be running around the con like a chicken with my head cut off, since I'm also in charge of gaming. Come shoot people. Yeah. All right. Have a nice one.